I'm going to be doing what for you guys would be the first day of this 2-week lab. The lab is a 10-dropper bottle mystery. So what you would have been doing on the first day is investigating samples of the known solutions. This again is a qualitative analysis experiment. We're going to be trying to identify 10 unknown solutions by mixing them together. Now they're unknown, but we have we know what the possibilities are. So we are going to be working with 10 known possibilities, and then we just have to identify the unknown solutions in their dropper bottles, which are numbered 1 to 10. So on this first day, we're only working with the knowns. So we're working with dropper bottles that are labeled. Now I wanted to start with your lab manual. On the second page of the lab manual, it mentions an example using just 6 known solutions. So here we have nickel sulfate, barium chloride, aluminum nitrate, bismuth chloride, sodium hydroxide, and sulfuric acid. In this example, those 6 solutions would also be in bottles that are labeled just 1 through 6. So the first thing you have to do is see what happens with these when you mix them with each other, and then do the same thing with your unknowns to try to identify what those unknowns are. So it's kind of a challenging, fun exercise that's based on looking at the reactions that certain solutions have with each other. Some of them will be acid-base reactions, some will be precipitation, some combinations won't react at all. So also in this lab manual, after introducing what the possible 6 solutions are in their example, they give you a table that tells you what happens when those 6 solutions are mixed with each other by showing it as a grid. So this grid in your lab manual shows, for example, the result of mixing aluminum nitrate, one of the knowns, with barium chloride. There's nothing that happens. There's no reaction there because neither one of those is an acid or a base, and neither one of those precipitates with the other anion. So the possibilities would have been maybe that aluminum might have precipitated with the chloride ion of barium, but that particular compound is soluble, so it wouldn't form a precipitate. The barium could mix with the nitrate, but that's also soluble. So neither one of the possible combinations you get there are insoluble, which means there's no precipitate, hence an NR. Notice that there's X's here along the diagonal, because obviously if you mix 2 of the same solutions together, nothing's going to happen. Also, by implication, all of the blanks below those X's also are not filled in because they would be repetitions of the combinations up here. And that's going to be similar in our 10 by 10 matrix that we're going to work with. But let's look at one of the ones where there is a reaction. So if we move down a little bit on this side, the barium chloride, which we already mixed with aluminum nitrate here, but if now we mix barium chloride with nickel sulfate, which would be this grid point, there's a P written in there, and that's because one of the 2 combinations you can get with these is insoluble, and the 2 combinations are either the barium with the sulfate or the nickel with the chloride. So one of those 2 forms a precipitate, and it actually just happens to be the barium with the sulfate. Barium sulfate is insoluble, and that's the precipitate that you would get right there. Now, what they didn't write in here, which you should, in your observations, you should write in there what the color of the precipitate is. And in that particular case, it's a white precipitate. White precipitate. Now, you could predict that would happen if you look up the solubilities of barium with sulfate and nickel with chloride. And that's one way of preparing a table like this. But the other way is just to actually mix the solutions together and see what happens. And that's what we're doing today. So you can see all the possible combinations that have been done here. Another example is if you mix sodium hydroxide over here with sulfuric acid, that's an acid plus a base. So the H there signifies that there's some heat released on that one. So as a matter of fact, anytime you have an acid and a base mixed together, you should see that there's heat released. Now you also see an H with the bismuth chloride mixed with sodium hydroxide, and that's not a reaction with the bismuth, but it's a reaction between the sodium hydroxide. The H part of it is a reaction between sodium hydroxide, the base, and the acid that this is dissolved in. If you look back at the original set of solutions, for bismuth chloride, it mentioned that it's dissolved in hydrochloric acid. Let me just put this sheet in there for a minute. So see, the bismuth chloride is in 3 molar HCl, and that's why you get an H on that particular grid spot. But you also get a precipitate. So there's two things happening on this one in their example. The sodium hydroxide and the HCl that's in here react, but also the bismuth forms a precipitate with the hydroxides. Bismuth hydroxide is insoluble, and that's where you get the P. Another thing that's possible in some of these combinations is that a precipitate might form when you first start adding the other reactant, but then it may dissolve. And that happens when certain complexes are formed in the solution. For example, that happens with aluminum nitrate. When you mix the aluminum with sodium hydroxide, the aluminum and hydroxide are insoluble, so you get a precipitate. But hydroxide also forms a complex with aluminum, which is soluble. So if you add excess hydroxide here, the precipitate that was originally formed dissolves, and that's what the D is for. So you get a P comma D. So anytime that happens, that you observe when you add excess of the anion and the precipitate disappears, then you would record that as a P comma D. That doesn't happen very often, but a couple of the knowns that can happen with. So let's go ahead and now I'm going to move to doing this kind of a table for us with our 10 by 10 matrix. So instead of having just this 6 set of solutions, we're going to have 10 solutions. Some of them are the same as in here, but many of them are different as well. So I prepared a grid for you guys for today that I want you guys to fill in at home, and I emailed this to everybody. This is a grid. It has the knowns filled in for you. So it's just like the one in your lab manual, except there's not blanks across the side and the top. There's these solutions. So these are the set of possible knowns that you're going to be working with the following week when you start mixing your different dropper bottles that are just numbered 1 through 10. All of those will be one of these knowns right here. So our job today then is to fill in this grid basically, and I'm going to do these combinations, at least the ones that I would expect there to be some kind of reaction. I'm going to do that for you and show you the results, and then it's your job to fill in your grid with the right notation. So anytime it turns cloudy, you would put a P down, and then you put the color if it's white, or some of the precipitates have a color to them. Another thing we're going to do today is identify whether any of these knowns themselves, the solution has a color to it, because that makes it really easy to identify if it does. And if I go back to the original sample grid they have in the lab manual, you can see that in their example, one of them does have a color, and they've just noted that here in the side. So you can add that to the ones that we're going to point out on this grid whose solutions have a color. And there's going to be 2 of them that have that color. There's also one of our knowns has a distinctive odor, and that's ammonia. So we want to note that as well, because when you guys do the unknowns, it's real easy to pick out the one with the color and also the one with the odor. So there's 3 of them of this list that you can determine just by direct observation of the solution. Okay, so now I'm going to turn the camera over to, so I have my little grid paper here as well. So on the grid, I can see that there's, the first grid point would be calcium nitrate and copper nitrate. I'm not even going to do that one because they're both nitrates. And metal cations don't react with each other unless they could possibly change oxidation state. I'm just going to leave that blank. You can go ahead and put NR in there on that first grid spot right there between the calcium and the copper. The next one, I'm just going to go across with the calcium here this way. So the next one will be calcium with barium chloride. Now for that one, something could happen because barium has a different anion than the calcium does here. Okay, so over here the barium has a chloride anion. That could possibly form a precipitate with the calcium. So we'll see if it does. First, I might have pointed to the wrong spot here on the first line here. Now we're going to do the barium chloride. So let's see. So I just find my calcium here, calcium, and then I'm going to add it to one of I'm mixing these things on a well plate. It's just more convenient to do that. There's only 6 spots across the well plate, and I'm not going to be doing all the combinations. So I'm just going to fill it up, maybe about 10 drops, should be about half of a milliliter in my well plate there in that first one. I know you can't see it right now. And then I'm going over here and looking for the barium chloride. Not the same number of drops of barium chloride, and I cannot tell that there's anything there. It's not turning cloudy, so I would conclude that that's no reaction. I'm going to carry it over here to my first solution right there, and you can see that there's nothing. It's just completely clear. There's no cloudiness at all, so that's no reaction. Now we go across. The next one would be then calcium with the aluminum nitrate. That one also I'm not going to do because that's another metal cation with metal cation. You can assume that's no reaction. So that's the calcium with the aluminum. Calcium with the nickel. Now I'm not going to do that one because the nickel wouldn't react with the calcium. But that does remind me though that I wanted to show you that the nickel does have a color to it. This is the solution of the nickel, and you can see that it's greenish. So that's one that you should take note of on your grid then. Okay. You should be writing in for the nickel, just put in parentheses, put the word green there, and you could also put it over here if you want to, under nickel there, so that you can immediately identify the nickel next week when you get in here. Okay, so now I'm going to go back to the camera. So the ones so far that we've considered are the calcium with the copper. I didn't do that one, but I said that could be no reaction. Calcium with the barium. Also, I did that one, and that showed no reaction. Calcium with the aluminum, you can assume that's no reaction because that's 2 cations. So there's no reaction so far. And then this other one, this next one with the nickel, you can assume is no reaction. Now the next one, silver with the calcium, I'm going to skip that one as well because that's another metal cation with metal cation. So I'm going to move along and now do the HCl. So I'm going to look at HCl with calcium, and I'll actually do put those two together to see what I got. Okay, so calcium again in this next well plate here. About 10 drops of the calcium in, and then I'm going to look at the HCl. Again, this should be similar to the barium chloride with HCl, except this is a more concentrated acid. This is 6 more instead of 3 more. Don't see any precipitate there either. So now the next one across there is sulfuric acid. So I'm going to put calcium with sulfuric acid. And the possible precipitate there could be calcium sulfate. So I want to see if calcium sulfate will give me a precipitate. So this would be calcium sulfate if it formed a precipitate. Not seeing any cloudiness there at all. Then we have, after that, ammonia. So now ammonia is also sometimes labeled as ammonium hydroxide. So ammonia contains in it hydroxide ion. So let's see if that will give us anything with the calcium. If we do see a precipitate, it's most likely calcium hydroxide that we would see. And you'll notice when we do these, a lot of times these metals are insoluble with hydroxide. I'm not seeing anything on that one either. So calcium does not precipitate with, at least with the concentration of ammonia that you have in ammonium hydroxide. One other thing about ammonium hydroxide, this is the one that you could identify by smell. So that's one of the other things you can do at the beginning when you're doing these analysis is take the lid off off each of them one by one and waft it for yourself to see if you can tell that smell, that ammonia smell. You don't want to sniff it directly because this is pretty concentrated, 6 molar. I'm not smelling anything. Should be. Oh yeah, that might be a better way to do it. Just sniff the cap. A little safer than sniffing a bottle directly, but you can definitely tell from the cap that it's ammonia. All right, so no precipitates on there either. So far we don't have any reactions. And then the last one on the calcium is sodium hydroxide. So I'm going to put that in the very last well here. Sodium hydroxide precipitates with a lot of it. I put 4 drops in there. I'm going to carry this over to the camera. Okay, so you can see here, this very last one I did, that's the sodium hydroxide with the calcium. These others don't have any precipitate, and then there's no cloudiness. I'm going to put a little bit more of the sodium hydroxide in here just to see if that's one of those that forms a complex with hydroxide. So maybe another 5 drops. And you can see it's still very cloudy. It didn't dissolve at all, so that's just a precipitate. So in that particular box on my grid here, that would be the first one that I'm coming across where I would put a P in. But anyway, you guys can put a P there in that, and it would be a white precipitate. So you could put white and then the capital P. Reaction. Now we go down to the copper. For the copper, the first one going across, because we've already done the copper with the calcium, so we don't have to repeat that. So the first one going across would be copper with barium chloride. So we'll see if copper forms a precipitate with chloride ion. So I'm going to do this again with the well plate. I'll just start in the second row here. And just to take some time now, copper is the blue one. So I'm not doing this to identify the copper because I can identify it immediately just with looking at it, but this may be helpful in identifying things I'm adding to the copper, because as soon as you guys start your experiment next week, you'll know which one is the copper because it's the blue one. Okay, so I'm going to put up some copper in all of these, and all the way across, just to save some time. Okay, because I'm going to add several things to the copper. So let's start out with the barium chloride, because that does have chloride ion in it, so it's possible I could get calcium chloride. And I don't see anything except that slight bluish greenish color, which I had already. So that's no reaction there for the barium chloride. The aluminum nitrate and copper, I'm going to skip that one because there's not really anything that I would expect to happen from that. Nickel nitrate, that's the green one. That's not going to tell me anything if I add those together, because I know I have the identity of both the copper and the nickel anyway. So I really only want to record things that might give me more information. So you can put a no reaction for the nickel. Silver nitrate with copper, that could possibly do something. Silver nitrate is a colorless solution. Silver could possibly, and I don't see anything with that. So silver nitrate doesn't do anything with copper. Then after that is hydrochloric acid. I'll go ahead and put hydrochloric acid with it, even though chloride ion we already know isn't going to precipitate with it, but it doesn't, so there's no change with the HCl either. Okay, and now I'm up to sulfuric acid. So again, this could be possibly a sulfate that could form a precipitate with the copper. And let's see anything here. Ammonia is the next one, ammonium hydroxide. Okay, now again, ammonia could reduce the copper also, or you could get a precipitate with the hydroxide in the copper. Copper hydroxide could form. So and that's real interesting. What the ammonia does, you can probably even see it just from there. See that blue color? That's after adding ammonia. The ammonia actually darkens the color of the original copper solution there. Now that doesn't give me any other information, but it's kind of interesting because I already know which one the ammonia is and I already know which one the copper is. So I didn't get any more information from that, but that is a reaction. It forms a darker blue. And then the last one's the sodium hydroxide. This one would give me some information if something happened, because again, you're assuming you wouldn't know which bottle is the sodium hydroxide before you did this. Now this is interesting. It's slightly changing the color. It's making it a more pronounced blue. That's this one. Let me show you this on the camera. Okay, so these are the last two that I did. Okay, this is with the ammonia. By the way, this could be a double check to make sure you know which one ammonia is without having to sniff it when you get that dark blue with the copper. This one is sodium hydroxide. You can see that's way different from any of these others. This is definitely a good way to identify sodium hydroxide, is by adding your unknown solutions to your copper and see which of those gives you that color blue. There's also a precipitate in the bottom of this. It's really hard to see by bringing it a little bit closer to the camera that there's some cloudiness in the bottom of that one. Okay, it's a little bit of, let's see if I tap it a little bit, but the bottom of that well plate has some solid that's settled to the bottom. So that's definitely a reaction. You get a darker blue. This is almost purple, but that's definitely a darker greenish blue, I guess you could say, and a precipitate with sodium hydroxide. All right, now I'm down to barium chloride. And I'm going to be adding some things to that. Now we've already added two solutions to it, or at least talked about it. Yeah, we've added calcium and copper. The next one that I could add to barium chloride is the aluminum nitrate. So that could possibly form aluminum chloride, so I'll do that one. Okay, that's giving me nothing, which is not surprising. if you remember from Chem 1, you had solubility rules. And the solubility rules for the halogens were that everything is soluble in the halide ions, except for lead 2 plus, the mercurous ion, and lead 2 plus, mercurous, and silver. Silver chloride is insoluble. But anyway, it's not aluminum. Aluminum is not insoluble with the chloride ion. So I'm not surprised that there's no precipitate there. Next one for barium chloride is nickel nitrate. So again, nickel isn't one of those that it's insoluble with, but I'll go ahead and try it anyway, because it is a different anion. But this one for barium chloride, I'm adding nickel. So I wouldn't expect there to be anything, but I'll do it anyway. Nickel is the okay, so there's nothing there. The next one is silver, so I would expect something to happen with the silver on this one. The silver chloride is insoluble, I know that. Now you're not going to necessarily know you're adding silver to this. Really, really heavy, milky white, which I'll show you in a minute. Then the next one after that's sulfuric acid. That's barium chloride with sulfuric acid. So that would be the, if it did precipitate, that would be barium sulfate. Let's try that one. A little bit. So that's the barium chloride. Sulfuric acid is here. Barium is an exception to the general rule that sulfates are soluble. So let's see if that holds up here. Very, very milky white there as well. Now for, again, barium chloride with ammonia. This might also form a precipitate because we have some hydroxide atom in there. I'm not seeing anything there that's very pronounced, but that there might be a hint of a little bit of a cloudiness there. It's kind of hard to tell. And then finally with sodium hydroxide with the barium chloride. Across the row there. So I got the barium chloride in there, and now the sodium hydroxide. And again, I got maybe a little bit of a cloudiness there. Not too much though. Okay, so let me go to the camera and show you these, the ones that did. Okay, so we have the ones that we had there before, right there, that row. Now we're on this row. I made a mistake on this one, put the wrong solution in, so I had to use an extra well plate here. So you can see, starting with this right there, we're getting a precipitate. So that's the silver with the barium chloride. So that's making silver chloride. So that's white precipitate. This one is this is the sulfuric acid with the barium chloride, and that is barium sulfate that you're seeing there with that white precipitate. Okay, so this is silver, this is the sulfuric acid. This one is ammonia, and this one is sodium hydroxide. So I had to go down here to get that last one. So you can see it with ammonia, that's this one right here. There's maybe a little hint of a cloudiness compared to some of these others over here. So you could say maybe a very slight precipitate on that one. This one is also a slight precipitate because that's definitely cloudy, but it's not nearly as dark as these. Okay, so that's the sodium hydroxide with the barium chloride. Okay, so a brand new well plate, aluminum nitrate. You could add the nickel, the silver, HCl, sulfuric acid, ammonia, and sodium hydroxide. I might as well add all those because I have there's 6 spots across the well plate. So I'll just put aluminum nitrate in all those. Okay. And the first one I'll add nickel nitrate, which is the greenish one. Wouldn't expect anything to happen there. That's a cation nitrate with another cation nitrate. Okay. It turns it a little bit of the color of the nickel nitrate, but that's not a reaction. And silver nitrate, I wouldn't really expect anything with that. Hydrochloric acid. I wouldn't expect anything with this either, because aluminum's not one of those exceptions to the chloride ions. There. And sulfuric acid. Again, I'm not going to expect anything there because sulfate isn't one I would normally. That's an exception. And again, there's nothing happening there. Ammonia, that could do something because aluminum hydroxide is insoluble. So let's see if I get anything with that. So I'm going to add ammonia here, ammonium hydroxide, in the aluminum. Okay, I only added 3 drops and I'm seeing a little slight precipitate. I'm going to stop there with that one, but I'm going to come back to it. And then finally sodium hydroxide with aluminum. And I have 3 drops of that also. So let me go and show you what we have. So here we are. Across this row here has the aluminum in it. The first 4 that I added, nothing happened. There was no precipitate. These last 2, though, you can see from there that they're a little bit cloudy. Let's see. No, that makes it worse. You really need a little bit darker background to see that. Okay. So what we're looking at here is these 2. Okay, so this one and this one, they both have a cloudiness that's not there in these other. So they both form a precipitate. This is ammonia, this is sodium hydroxide. Now I only added 3 drops of each of those because I wanted to show what could happen if you add more of either one of these to the aluminum. So I'm going to take the ammonia and I'm going to bump that up to 10 drops. Okay. And it looks like there's still a precipitate there. I'm going to take the sodium hydroxide and add more of those as well. Okay. Look what happened with that. This one actually got cloudier. This one cleared up. So this is where and this is exactly the same compound that's in your lab manual with the aluminum and the sodium hydroxide. For the ammonia, you'd put P, white precipitate. Here, you'd put P, D, because initially you had a precipitate with just 3 drops, and then it dissolved after bringing that up to 10 drops. We're going to continue with the next one on our table, which is nickel. And again, we've done some of those with the nickel already. I'm going to add nickel all the way across first. Silver nitrate with nickel. And I don't see anything there. Then we have HCl with the nickel. Nothing really discernible there. And sulfuric acid. So if I get a precipitate, it would be nickel sulfate. That one. Okay. Then I have ammonia. So the nickel started out as green. When I add ammonia to it, it also darkens. It turns to a bluish. Let's see, that's this one, and I'll show you that under the camera. Then the last one is sodium hydroxide. Okay, so this is where we put nickel with ammonia. See, it's bluish. There's no precipitate in there, though. No precipitate. So it just changed the color, darkened it. Well, no, actually changed it because it started out green. This I didn't put anything in. This was the nickel solution with sodium hydroxide. So it's got that greenish color and it's got a precipitate. So it almost looks like a greenish precipitate with the nickel. So again, that can help you identify the sodium hydroxide solution. Now, silver nitrate. Remember, we've done a lot of these already. So with silver, we only have 4 of them left to go. First one under the silver would be hydrochloric acid. Definitely expect something to happen there. This chloride is insoluble. But we'll just see what it looks like. Very, very milky. Then sulfuric acid. Nothing there. Then ammonia. Possibly. And then with sodium hydroxide. Look at these a little closer. Okay, so this is what I'm got for the silvers. This row right here, these 4. So this one is the hydrochloric acid, just as you'd expect, very milky white precipitate. This one is the sulfuric acid, nothing there. This is the ammonia. Look, I can't see anything in that either. Okay, so the ammonia and the sulfuric acid, those are both no reaction. This is very interesting though. This is a sodium hydroxide with the silver. Look at that precipitate. It kind of looks greenish on the camera, but it's really a brownish color right there. So remember that, because that could either help you identify the silver or the sodium hydroxide. You probably will have identified sodium hydroxide by the time you get to this one, but just kind of keep an eye out for it. When you see that brown, you know that that is a combination of silver and sodium hydroxide. Nothing else is going to give you that brown precipitate in our set of unknowns. It's just you have to figure out which dropper bottle is which. Hydrochloric acid, and there's 3 to check with that one. So HCl, that one. And I'm going to put that in 3 well plates here. About 10 drops each. And then go to the last 3 here, sulfuric acid. And we know that these are both acids, so you wouldn't expect there to be any neutralization reaction. And there's no metals in it, so you wouldn't expect there to be any precipitation either. And one of the things you can check when you're adding acid and a base is the bottom, see if it gets warm. This is an acid and an acid, so there's no reaction there. The next one, though, is ammonia. That's a base. So when we do ammonia with the hydrochloric acid, there could possibly be a neutralization there with that releases heat. There will definitely be a neutralization. It's just whether you can detect it or not. And then also something else happens with ammonia and hydrochloric acid that I'll try to point out to you when I get a close-up. Be able to kind of see it here even. Tell, but there's sort of a smokiness. It's not a precipitate, but over the well plate, there's some smoke. And that happens. That's distinctive with hydrochloric acid and ammonia, because both of those also are in the air. Hydrochloric acid has a vapor pressure of chloride ion, and ammonia has a vapor pressure of of ammonia. So you get ammonium chloride as a smoke over the top of it. I'll demonstrate that again under the other camera. Also, if you put your finger on the bottom of that, on the bottom of the well plate, when I putting my finger there, I can tell that it's a little bit warm, because that is a neutralization reaction. I should have done that right away. It would have been more noticeable. And then another thing you can look at is, and your book mentions this, I can also see that there's a little condensation around the well plate as well, because what's happening is, because it's releasing a little bit of heat, some of the water evaporates, vaporizes, and it deposits, it condenses on the sides of the well plate. So that also shows that there's some heat being released. Then the last one is the sodium hydroxide with the HCl. And same kind of thing. Now this one shouldn't smoke. It doesn't. But you should be able to detect a little bit of heat. And definitely I can see the condensation around the sides. So I'm just gonna bring these up. So what I want to do is zero in here. Okay, these are the three that I did already. This is not interesting. That's sulfuric acid with HCl. That's no reaction. This is sulfuric acid with ammonia. This is the one that formed the smoke. This is sulfuric acid with sodium hydroxide. This heated up, but it didn't form any smoke. And both of these had condensation on the inside of the well plate. I want to see if I can maybe bring it close enough so you can see the condensation. So this is the one that has condensation in it. You can see the sides are sort of cloudy. That's the condensation. I want to redo the sulfuric acid, the HCl with the ammonia, so that I can show you the smokiness that happens with that. So I'm just going to, right below this well plate, this is the one I already did. I'm going to do exactly the same thing over here so that you can see that smokiness. Okay, so here's the ammonia. I'm going to add 5 drops. Can you see the vapor swirling around that? That's actually smoke that's occurring over the surface of that one. And you can also see that the sides, there's some condensation on the sides of that well plate as well. The next one is sulfuric acid. There's only 2 things to add to that. I'll put sulfuric acid into this row, second to the bottom row here. Now, I have ammonia. So sulfuric acid is an acid, obviously. Ammonia is a base. So for that one, I might be able to detect some heat. I put almost 10 drops in that one. And it's just not quite enough of a reaction to detect the heat. But I can see the condensation on that. So even if you don't feel the heat with your finger, because this is plastic, it's kind of hard for the heat to penetrate through, but you do get the condensation. And then sodium hydroxide also should be a reaction, neutralization. Again, I don't feel the heat, but I see that condensation. So I'll see. Okay, so we're talking about these right here, these 2. And if I bring that a little closer, might be able to see a little bit of condensation on that one and on this one. But just right around the edges of those well plates, you see that there's a little bit of moisture that's condensed on there. That shows that there was heat released. So on those, you should write the letter H for your observation. So now I'm down to ammonia. That's the second to the last line on the grid. And there's only one thing to put on there. Because I've done all the other combinations. So this is ammonia with sodium hydroxide. That's a base with a base. So I would not expect there to be any reaction. Two bases. Mix them together. There's no condensation, there's no heat, so there's no reaction. Okay, so that's all the different combinations that we needed to do for this grid. And I showed you close-ups of the ones that did react. So hopefully you'll be able to fill in that grid. And then bring that grid with you next time. That's going to actually be something you're going to turn in as part of this lab report. And then you'll fill in the table that identifies your unknowns. I'm not actually going to have you do another grid for the unknowns because I don't think that gives us any help to do a grid. The only grid you'll do is this known grid, but you'll use that information to identify the unknowns. All right, these are the pages from the lab report, the lab manual, and this was a page they had in here for the grid we just did, but they didn't have these spaces filled in, so you don't have to turn this in. By turning this sheet in, you'll be doing the same thing, except this already has those known values filled in. The only thing I didn't do, I didn't put a place for your name at the top of this, so just make sure you write your name in before you turn in that as a lab report. And I'm allowing you to just go ahead and write directly on this grid because your data is coming from a video. So you don't have to use your lab notebook for this part of the experiment. I do want you to use your lab notebook. Whoever's here next week working with the unknowns. So the next thing was in your lab manual was this grid. And this has just the numbers 1 to 10 across the side and the bottom, or bottom and side, and then a place for your observations. I don't want you to fill in this grid. You do have to write your unknown number here. If you want to, you can, and you can turn it in. You can turn it. I want you to turn in this page, but just with the unknown number in it. It's not really helpful, I don't think, to even fill in the grid. What I do want you to fill in, though, is this page, this third page, where you have the calculated data, which basically means here's your unknown numbers for your dropper bottles. Your identities would go here, so you write in whatever the formula is for that compound, and then your rationale. For the rationale, I want you to write down which combinations helped you identify that particular compound. So if you identified the silver nitrate because it turned white when you added hydrochloric acid to it, then put that down here as your rationale. Or if you identified sodium hydroxide because you got a brown precipitate when you added it to silver nitrate, put down whatever you're at, like NaOH plus AgNO3 gave brown precipitate. Something like that. So next week is when you'll be collecting the data you'll need for 1 through 10 on this sheet. So one last thing that I wanted to make sure that you were aware of. I did point out and showed you that the copper nitrate solution is this bluish color. So it's kind of a blue-green. I'll give you that. Okay, so the copper nitrate is kind of a blue-green, which we said already. The nickel nitrate is greenish. Okay, so you can identify both of those just by their color. Yeah, one of them should stay with the same there. One of them is blue-green, one of them is just green.